Hello, everybody, and welcome back. I hope you're doing well, and hopefully you've already tried question number 3 on our 2016 Euclid. Just like question number 2 that we just did, we've got 3 parts, 2 light bulbs, and a written portion. And what have we got for A? In the diagram, point B is on AC, F is on DB, and G is on EB. Okay. Then we've got a bunch of named angles, P, Q, R, S, T, and U. And we want to know what's the value of P plus Q plus R plus S plus T plus U. So everything here is in degrees. Okay. Now, I see no other angles. Nobody's saying anything like 30 degrees or anything like that. So there's probably going to be a sort of a nice theory way to answer this. And I would expect things like multiples of 90 or 180 to pop up. But let's see what we can do. Get ourselves a fresh sheet of paper. We'll copy this sort of picture. So since they don't really specify a whole lot, like there are no midpoints or this angle is this, or these lengths are twice as long as this. This is really sort of a generic construction of 2 triangles added together, and then you put a third one in between. What were the D and E? Okay, so we've got P, Q, R, S, T, U. What I'm going to do is, well, I've got one triangle here, one triangle here, and one triangle here. I'm going to give names to the other angles in here. And you'll notice we are told that they form a line. AC is a line, so I know X plus Y plus Z is 180 degrees. But I also know, looking at triangle ADB, that P plus Q plus X is 180 degrees. And looking at our middle triangle, R plus S plus Y is 180 degrees. And then T plus U plus Z is 180 degrees. So if I add these 3 up, I get P plus Q plus R plus S plus T plus U plus these extra X, Y, and Z that I've added in. And that's going to be 3 times 180. Or you could say 540 degrees. But I know what X plus Y is, so I can really just say, well, subtract 180 from both sides. I'll get P plus Q plus R plus S plus T plus U. 540 minus X plus Y plus Z. But that's minus 180 degrees because X, Y, and Z formed a line. So that's going to be 360 degrees. So if you have 3 triangles made this way, they make a full circle together. That's kind of cool. So we just need the final answer of 360 degrees. It is a light bulb question, so we've got it. We put a box around it. We can move on. All right, B. Let n be the integer equal to 10 to the 20 minus 20. What is the sum of the digits of n? Now, 10 to the 20 is a little too big to display on my calculator, so what can I do here? Well, I suppose if we wanted to, we could actually, 10 to the 20 isn't so bad, we could write out all these zeros and subtract 20. I didn't do enough. But you could do that if you had the time, but you don't really want to waste time writing a lot of zeros and doing a lengthy by-hand calculation. Let's look at some simpler examples, especially because if in the future I saw the same question, but it was 10 to the 200, well, I wouldn't be able to write all that out. So let's just look at, say, 10 to the 2 minus 20. What are we left with? Well, just 80. Sum of the digits, 8 plus 0, 8. What if it was 10 to the power of 3? So that's a 1 followed by 3 zeros. Well, you'll get 980. And so sum of the digits, 9 plus 8 plus 0, 17. What about 10,000? Right, the zeros go through, and then you borrow, you get 2 there, 9 and 9 there. Oh, sorry. That's an 8. No, that's a 2, that's an 8. So you get 9 plus 9 plus 8 plus 0, which is 26. And we'll do one more, just in case you're not catching the pattern yet. Okay, subtract, the zeros go there. 9, 9, 9, and a 1. 10 minus 2, 8, and then the 9s come down. So if I'm doing 10 to the 5, I get 3 9s. If I was doing 10 to the 4, I get 2 9s. 10 to the 3, I get 1 9. 10 to the 2, I get 0 9s. So 10 to the 20 minus 20 will be a bunch of 9s. How many 9s? Well, take away 2 from 20, 18 9s. An 8 and a 0. And if I want to add those up, that'll be 18 times 9 plus 8 plus 0. The 0 doesn't do anything, and if we just grab our calculator here, or, you say, well, 18 is 9 times 2, so 2 times 9 times 9, 9 squared is 81 times 2, 162, plus 8 plus 0, and we get 170 as our answer there. Okay? So 170, and again, it's another light bulb, so we just put it in the box, and we can move on. But now we've got a written answer required for C part. A parabola intersects the x-axis at 2, 0, and 8, 0. The vertex of this parabola is at V, which is below the x-axis. So already I'm sort of picturing my vertex down here, and there's 2, 0, 8, 0. I don't know what the question's asking yet, but this is what immediately pops into my head. If the area of triangle VPQ is 12, determine the coordinates of V. Okay. So let's go back. We'll draw a nicer picture. Mine didn't look quite like a parabola. So I'll put 2, 0 here. 8, 0 here. V is down here. So we come down a certain bit. Now, one of the nice things about parabolas is, and we'll say this right away because we're going to need to use this fact, vertex is halfway between the roots of the parabola. Okay, you can actually get what's called the axis of the parabola, and it goes right through. The parabola is symmetric about this point, so the vertex must lie on it, and the roots are spaced evenly between it. So V has an x-coordinate. Well, just average these two values. So 2 plus 8 over 2, you'll get 10 over 2, it's 5. So V is 5 something. But what is that something? Well, let's say, let V be at 5. We could call it Y. I'm going to call it V just because, well, it's at coordinate, or it's at point V. So V is negative. So whatever this height, this distance here is, it's going to be negative V. Because V is negative. They tell us the point V is below the x-axis. So this distance here is negative V. Okay? But what do they tell us? Well, they tell us the area of this triangle. So here's the height of the triangle, negative V, and I can see the base is negative 6. So 12 is equal to the area of triangle PVQ, and that's 1/2 base times height, and that's 1/2 base is 6 times negative V is the height. You can even mention if you're not sure if somebody's going to follow along, you can just say, well, the height will be negative V because we need it to be positive, and we know V itself is negative. The negative of a negative is positive. Okay, and so that's 3 times negative V, so 12 is 3 times negative V. Divide by 3 on both sides. Negative V is 4. So V is at negative 4. So my the coordinates for point V are 5, negative 4. Okay? We've justified it. We explained the vertex halfway between. That gives us the x-coordinate, which has nothing to do with the area or anything like that. And then to figure out the y-coordinate, we draw a nice picture. We can see the base, the height, everything there. And we are told it was 12, right? I just want to double check. Yeah, it's 12. So there we go. That's C. Everything explained nice and neat. So up next, we're going to take a look at question number 4. I will see you for that in the following video. Take care.